Hello, this is Dr. Rashmi Deshpande on my channel RD Physics. This is a course on atomic and molecular physics, and we are going to continue our discussion of hydrogen atom. We have already derived the Schrodinger's equation for hydrogen atom in spherical polar coordinate system, and we have reduced it into three differential equations, that is R equation, theta equation and phi equation. Today we are going to see how do we solve the phi equation and how can we obtain the quantum number, that is magnetic quantum number ml, which is related to phi equation, then principal quantum number n, which is related to R equation, and the orbital quantum number L, which is related to the theta equation. So let us start with the easiest one, that is the phi equation. So phi equation, we have seen that it is the second order differential equation given by d2 phi by d phi square plus ml square phi is equal to 0. Remember, this small phi is the variable phi and capital phi is function of phi, that is a function of angle phi. Okay, now if we solve this second order differential equation, the solution will be of this form: a e raised to I ml phi. Okay, so it is a complex number. Capital A is a constant of integration, which is also a normalization constant for the wave function, and ml can take positive or negative values. Now we want to find out what are the possible values of ml. So these values, these possible values of ml can be obtained by considering the condition for the well-behaved wave functions or acceptable wave functions in quantum mechanics. One of the conditions for the acceptable wave function is that they have to be single valued and continuous. So psi has to be single valued, and because psi is a function, psi is a product of r, theta and phi, so therefore phi also must be single valued. Now what is the meaning of psi must be single valued? That the value of phi at angle phi and at angle phi plus 2 pi has to be equal, because these two angles are necessarily equal. Phi and phi plus 2 pi, these are the same angles because every angle repeats itself after a rotation of 2 pi radian. So if this is true, then this condition also has to be true. Okay, so if we expand this, e raised to I ml phi multiplied by e raised to 2 pi I ml is equal to e raised to I ml phi. So if we cancel e raised to I ml phi from both the sides, because it cannot be equal to 0, so therefore we get e raised to 2 pi I ml is equal to 1. Now 1 is a real number. I can write this number as 1 plus I0. I can write e raised to 2 pi I ml as cos of 2 pi ml plus I sin 2 pi ml. So this is the real part, this is the imaginary part, okay, which is equal to this real number 1. As I have already told, I can write this one as 1 plus I0. So if we equate the real part and imaginary part on both the sides, then what do we get? Cos of 2 pi ml has to be equal to 1, that is the real part, and sin of 2 pi ml has to be equal to 0, that is the imaginary part. Therefore, these two conditions are simultaneously satisfied only if 2 pi ml is even multiple of 2 pi. Okay, so 0 plus minus 2 pi plus minus 4 pi plus minus 6 pi, these are the possible values of 2 pi ml, and so possible values of ml are 0 plus minus 1 plus minus 2 plus minus 3 up to plus minus L. Now why that upper limit of plus minus L, that we will see afterwards. This ml is called as magnetic quantum number. The reason is it determines the splitting of energy levels in the presence of magnetic field. that we will see afterwards. Now the theta equation. The solutions of theta equation, though we are not going to derive them, these are the polynomials which are called as associated Legendre polynomials, associated Legendre functions. The solutions of the theta equations exist only if L satisfies one condition, that it is an integer such that L is greater than or equal to modulus of ml. So ml can be positive or negative, but L has to be positive integer and it has to be greater than or equal to modulus of ml. L is called as orbital quantum number. The reason is it is related to the magnitude of orbital angular momentum. The R equation. If we find out the solutions of R equation, these are also polynomials which are called as associated Legendre functions. We are not going to derive it, but we should remember that the solutions of this R equation can be found for any positive value of E. But please remember that hydrogen atom is a bound system and every bound system has negative energy. So for negative E, the R equation has a solution only for certain values of E. So here comes that condition, only for these values of the energy the R equation will have solutions. Okay, so this N is called as principal quantum number or total quantum number. It is a positive non-zero integer and it is equal to or greater than L plus 1. So therefore L can take values from 0, 1, 2 up to only n minus 1. N is called as total or principal quantum number and it determines the quantization of energy. So far we have seen these three quantum numbers n, L and ml. So the wave function psi is dependent upon these three quantum numbers n, L and ml. The R function is related to n and L, theta is related to L and ml, whereas phi is related to ml only. These are the possible values of n, L and ml. Okay, students, you have to remember the possible values and how to derive the possible values of n, L and ml. So if we know or if we are given the principal quantum number, then we should be able to determine what are the values of orbital quantum number and magnetic quantum number. So here is one example. Suppose if n is equal to 2, then what are the possible values of L and what are the possible values of ml. So we can see here that if n is equal to 2, because L can take values from 0 up to n minus 1. So these are the only two possible values of L. For every value of L, determine what are the possible values of ml. So for L equal to 0, only a single value of ml, that is 0. And for L equal to 1, ml can have three values, that is minus 1, 0 and plus 1. So in this fashion, if we are given any principal quantum number, we should be able to derive the possible values of the other two quantum numbers, that is L and ml quantum number. That's all for today. Thank you very much.